In this video, we're going to bring a number of the concepts that we've considered together to think about general transformations. Now, these are not all linear transformations. In other words, they can't all be achieved just by matrix multiplication. So some of them involve translations, which remember would mean adding or subtracting matrices. But we'll still try and do them using matrices and see how we can analyze the situation. So to do this, let's grab an example, and I've just gone with the first question from exercise 18H in the textbook, and here's what it says. It says, find the transformation that rotates the plane by 90 degrees clockwise about the point 2, 2. Check your answer by showing that the point 2, 1 is mapped to the correct point. Okay, so we're talking about rotating the plane by 90 degrees clockwise, and we're familiar with how to do that as long as it's rotation about the origin. So we've got a matrix which will rotate the plane clockwise or anti-clockwise about the origin, but this is saying about the point 2, 2. So let's visualize what we've got here. We've got the plane, and rather than rotating everything clockwise around the origin by 90 degrees, we actually want to rotate everything about the point 2, 2 by 90 degrees. So any point which is sitting out here, rather than rotating it about the origin, we're rotating it around this one here. So rotating that one 90 degrees, it would end up there, and so on. So how could we think about doing that? Well, the way that we can approach it is to say, well, because we've got a matrix for rotation about the origin, why don't we shift or translate the whole plane such that the point with coordinates 2, 2 is now sitting at the origin. So I'm shifting every point in the plane in that same, doesn't matter where the points are, they're all being shifted by that same translation, which would shift the point 2, 2 to the origin. Then I'm going to rotate the plane by 90 degrees about the origin, which I know how to do. And then, once I've done that, I'm going to shift everything back. So just basically reverse that initial shift to get the whole plane back where it started. So here are the steps that I just talked about doing. So let's sort of write them out first of all and think about what we need to do to achieve them. And then let's try and write a sort of matrix statement. So we're going to translate the plane such that the point 2, 2 is translated to the point 0, 0. Alright, so now the plane should be centered at the origin. The second thing that we're going to do, so step 2, is that we're going to rotate the plane 90 degrees clockwise about the origin, and we've got a matrix to do that. And then the third thing is that we're going to translate the plane back to where it started. In other words, translate the plane such that the coordinates point 0, 0 goes back to 2, 2, and that will translate everything back to where it started. So let's quickly think about the matrix operations that we need to do for that. So to translate the plane such that the point 2, 2 ends up at the origin would mean we'd need to add -2, -2 onto every point. Okay, so any coordinate point we need to subtract 2 from the x and 2 from the y. Because that brings 2, 2 to the origin, it will bring every other point to the correct place. Rotating 90 degrees clockwise about the origin, we would need to multiply by the matrix cos -90, negative sine -90. Now remember, these are -90 because we're rotating clockwise. and the matrix that we've got by default is for anti-clockwise. And then to translate the plane back so that the origin went to 2, 2, and every other point did likewise, we would need to add 2 and 2 onto the x-coordinate and the y-coordinate. Alright, so there are the sort of sequence of steps that we would need to do. Now let's think about then how do we do those sort of in the right order. So the final image point for any of these, well, if I do my cos negative 90, sine negative 90, so cos negative 90, let me write it in here just so we know where it's come from, cos negative 90, negative sine negative 90, sine negative 90, and cos negative 90. But before we did that, we needed to do the transformation. So here's kind of where we're starting. I'm starting by doing the shift. Okay, so that's represented by the bit in brackets. So here's the bit that I'll do first. Then I'll do the rotation. And after I've done that, then I'll need to finish up by doing the translation back to where we started. So this is going to happen first. That's going to be step 2, and then this is going to be step 3. And the way that I've written those matrices, it should happen in that order, shouldn't it? So the brackets occurs first. Now let's simplify this here. So we know cos 90 or negative 90 is 0. We know sine negative 90 would be negative 1, so the negative, that would be positive 1. Now, in the brackets here, I'm going to have x minus 2, y minus 2, and then I'm going to be adding 2 and 2. So let's do the matrix multiplication, and in some ways I don't even really need those brackets anymore, do I, once I've done that operation? So let's remove those. So doing the matrix multiplication here, we get 0 times that plus 1 times that, so it should be y minus 2, and then negative 1 times that, so that'll be negative x plus 2, and then 0 for the other one, plus 2, 2. So therefore, what do I get here? Y minus 2 plus 2, which is just y, negative x plus 2 plus 2, which is negative x plus 4. Alright, so if I was to write this out sort of as a rule, I'd have the point xy is being transformed to the point y, and either negative x plus 4, or I guess I could say 4 minus x, but I'll write negative x plus 4. Alright, and then the question did actually have another part, didn't it, which was to say, let's check the answer by showing that the point 2, 1 is mapped to the correct point. So for 2, 1, it's going to be mapped using my rule there, xy goes to y and negative x plus 4, so y is 1, and then negative x plus 4 is negative 2 plus 4, so that's going to be to the point 1, 2. So let's do a quick sketch and see whether that sort of makes sense. We're starting here's the point 2, 2, and we're saying what happens to the point with coordinates 2, 1. So there's 2, 1, and we're saying let's rotate it clockwise by 90 degrees about that center. I might move this over to the other side here so it's not in the way. So if I'm going to rotate this by 90 degrees around about that center in a clockwise direction, it's going to end up there, isn't it? So that's a 90-degree rotation in a clockwise direction. So that now has coordinates 1, 2. And that's indeed what my rule gave me there using the matrix operations.